So we are going to look at matrices and transformation. This is a Form 4 topic, first topic. So transformation, we are going to combine what we learned in matrices in Form 3 and what we learned about transformation in Form 2. Specifically in Form 3, we'll be dealing with multiplication of matrices. So a transformation, we can start by saying a transformation is a change in position. We have position, we have size, and or shape of an object. So we discussed several transformation which include 1, reflection. Then 2, we also discussed rotation. Here we can put capital R. We have enlargement. And translation. And translation. Number 4, translation. So in reflection, this is when we have an object like we use a normal mirror. We see our image on the other side of the mirror. Rotation, we talk of an angle. Enlargement. So you can just have a look at what you did in Form 2 in case you have forgotten. You check on the topic of transformation. Now, in this area, we are going to say that a matrix can represent a transformation. That is why I have said that we are going to combine what we learned in matrices in Form 3, specifically multiplication, and we combine with transformation. So we can have a matrix representing a reflection, can have a matrix representing a rotation, we can have a matrix representing an enlargement, or even a translation. So we are going to take an example and see how a matrix can represent a transformation. So let's consider triangle ABC, in which A, the coordinates of A are 2 and 1, coordinates of B are 5 and 1, and we have the coordinates of C is 5, 4. So we can be able to plot this triangle. We can write the position vectors of A, B, and C. So we can say OA is equals to 2, 1. We just invert or write it in column form. Then we have our OB is equals to 5, 1. And we have our OC. These are position vectors. We have 5 and 4. Now, if we combine, we can form a matrix using the position vector. So we can have 2 and 1. That is our A. We are forming a matrix. So we have 2, 1. We have 5, 1, and we have 5, 4. So this is a matrix that can be formed with the A, B, and C if we combine them. Let's consider a matrix. We can say matrix P is equals to minus 1, 0, 0, and 1. We can multiply this matrix, the matrix P, by the matrix formed by the vertices of the position vectors of the triangle PQ ABC. So we can write this as minus 1, 0, 0, 1, and we multiply by we can have this is 2, we have 1, we have 5, we have 1, we have 5, and we have 4. Remember how we used to multiply the matrices? So we multiply minus 1 multiplied by 2, that will give you minus 2. 0 multiplied by 1 is 0, so you add minus 2 plus 0 is equals to, so you'll be able to get this is equals to minus 2. Again, minus 1 multiplied by 5 is minus 5. 0 multiplied by 1, you get minus 5. We can say minus 1 times 5 is minus 5. 0 times 4 is 0, so we get minus 5. And then we have 0 multiplied by 2 is 0. 1 multiplied by 1 is 1. We have 0 multiplied by 5 is 0. 1 multiplied by 1 is 1. And we have 0 multiplied by 5, that is 0. And 1 multiplied by 4, we get 4. So that is our matrix that we get. There's a product of these two matrices. We can say, since we had already identified this is our A, that is our A, this is our B, and this is our C, and now we have gotten new vertices, we can name this as A prime and B prime and C prime, and therefore we can be able to write the coordinates of A prime. We will say it is minus 2, 1. We can write the coordinates of B, and we get it is minus 5 and 1, and we can get the coordinates of C prime, which is minus 5 and 4. So those are the coordinates. Now what we do next is to plot these two triangles and see what happens, or the relationship between triangle ABC and triangle ABC prime, and then we'll be able to describe whether there is any transformation, and if there is any, then we'll be able to describe that transformation. So this is the grid that I'm going to use, and we had said that our A was 2, 1. Our B was 5 and 1, and our C is 5 and 4. So these are the coordinates of that point. Then we have our product. When we multiplied, we got A, the coordinates of A, we got it is minus 2, 1. We got it is minus, that is the coordinates of B prime is, we have minus 5, 1, and we have our C prime, which we got is minus 5, 4, minus 5 and 4. So we are going to plot these two triangles and see what kind of what is the relationship between them. So we are going to say this is our origin. So we say this is 1, this is 2, this is 3, this is 4, 5, we have 6, we have 7. This is our x-axis. Okay, I've already taken care that we don't have the negative y, so all the values of y are positive. So we have minus 1, minus 2, minus 3, minus 4, minus 5, and minus 6. Then that is we have y is 1, 2, 3, 4, 5, and 6. So this is our y-axis. Always remember to label your axis. So we're going to start with our A. So the position of A is 2, 1. So this is where we have our A. The position of B is 5, 1. So that is where we have our B. And position of C is 5, 4. So 5, 4 is there. So this is where we have our C. And we are going to join the 3 points to come up with a triangle. So this is our triangle ABC. After joining the 3 points, then we are going to plot the triangle ABC prime. So A prime is minus 2, 1. We can put our A prime there. Our B prime is minus 5, 1. Minus 5, 1. So we have our B prime there. And our C is minus 5, 4. So this is where we have our C prime. And then we join the 3 points to come up with the image or the triangle ABC plane. So this is the image of triangle ABC plane, and we have obtained this triangle after multiplying minus 1, the matrix minus 1, 0, 1. We multiplied by the matrix formed by the object. We can call it the object, which is 2, 1 and 5, 1, and we have 5, 4. We got the product of the matrix. The matrix is minus, that is minus 2, 1, minus 5, 1, and minus 5, 4. Observing this triangle, we can clearly say, because we are now combining matrix and transformation, what has happened to this triangle, that is triangle, the object, if you call that the object, and the image. The relationship between the object and the image is that this triangle is a reflection, that is ABC plane is a reflection of triangle ABC, and therefore we can conclude that a matrix, so we can conclude that the matrix minus 1, 0, 0, 1 represent a reflection in the line y-axis, or mirror line is the y-axis. So that is what I wanted us to achieve, to show that a matrix can represent a transformation. So that now we have combined the matrices and transformation, showing that a matrix can represent a transformation. So I hope that is clear. We are going to do several examples to show various matrices that represent various transformations. So in our example 1, we are told identify the transformation represented by the matrix we have 0, minus 1 and 1, 0. So this is the matrix of transformation. And now with that, we have seen in our first example that a matrix can represent a transformation, and I'm going to use the same triangle. So we have our triangle A. Our A is the same triangle, 2, 1. Our B is 5, 1, 1, and our C is 5, 4. So these are the coordinates of the triangle that we are going to use to demonstrate the transformation represented by this matrix. Now from there we can be able to form a matrix. So we can form a matrix of from the coordinates. That is, we say OA is equals to 2, 1. That is a position vector. OB is equals to 5, 1, and OC is equals to 5, 4. We can combine all these and form a matrix, which we say it is. We can say it is 2, 1, and we have 5, 1, and we have 5, 4. So this is a matrix where we can say this is our A, this is our B, and this is our C. So that is a matrix formed by the position vectors of our triangle ABC. From there, we pre-multiply this matrix by the transformation matrix, that is 0, minus 1, and 1, 0. We have 1, 0. We multiply by 2, 1, 5, 1, and we have 5, 4. Once you do that, what we do is we take 0 multiplied by 2, that will be 0, and then we minus 1 multiplied by 1. So you add 0 plus minus 1, that will give us minus 1. You do the same to 0 multiplied by 5, you get 0, minus 1 multiplied by minus 1, we get minus 1 when you add with 0. So 0 multiplied by 5, you remember how we multiply matrices in form 3. 0 multiplied by 5 is 0, minus 1 multiplied by 4, that is minus 4. So 0 plus minus 4 is minus 4. So we are through with that row, and we go to the second row, that is 1 multiplied by 2, that is 2. 0 multiplied by 1, you get 0. So 2 plus 0, you get 2. You do the same. 1 multiplied by 5 is 5. 0 multiplied by 1 is 0. So 5 plus 0 is 5. 1 multiplied by 5 is 5. 0 multiplied by 4 is 0. 5 plus 0 is 5. So we can say, since we had already identified this is our A, B, and C, it means that this is the image A, B, and C prime, implying that we can be able to write the coordinates of this our image A prime is minus 2, not minus 2, but minus 1, and we have 2. Our B is minus 1 and 5, and our C is, this is prime, A B prime, so this is minus 4 and 5. Now what remains now is for us to plot these two triangles and see whether there is a way we can describe the object and the image in terms of transformation. So this is the matrix that we had. So we had 0, we had minus 1, we had 1 and 0, and we had our triangle. We had A. The coordinates of our triangle is 2, 1 of A, that is B is 5, 1, and C we had 5, 4. After we multiplied the matrix formed by the vertices or position vectors of a triangle, we got the image of A, which is minus 1, that is 2. After we multiplied, we have a B prime, we got it is minus 1, we have 5, and we have C prime, it is minus 4, 5. So we are going to plot these two triangles and see the way they look like. So let's go ahead and have our axis here. So we have our, let's say that is our origin. We have 1, 2, 3, 4, 5, 6. That is our x-axis. So we have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Always, okay, when you are doing that, you can you of course you have a bigger graph. I'm using a smaller one because of space, so you always make sure that you look at the points, the coordinates which you want to draw. For example, if you look at our object, it is on the positive side of y and positive side of x. If you look at our image, x is negative, but the values of y are negatives, or positive rather. So we have 1, we have 2, we have 3, we have 4, we have 5, and we have 6, and this is our y-axis. So we plot our object. It is 2 and 1, so that is our A. Our B is 5, 1, so what is our B? It is the same triangle we had plotted, so this is our C. Now our image, we join the 3 points to come up with a triangle. So that is our triangle ABC. Now we are going to plot the object, which let me say this is our A minus, that is minus 1, 2. So this is where we have our A prime. Our B prime is minus 1, 5. This is our B prime, and our C prime is minus 4, 5, minus 4, 5, minus 4, 5. So this is where we have our C prime, and we join the 3 points to come up with the that one is not correct. We change that. It is minus 4, 5, minus 4 and 5. I think it is B that is not correct. So having obtained our object, what we do is we get image. Now our image is at minus 1, 2. So that is where we have our A prime. Our B prime is minus 1, 5. So that is where we have our B prime. And our C is minus 4, 5. Minus 4, 5. So that is where we have our C. And with the 3 points, we join them to come up with the image of this triangle. So that is our triangle, our image. So we can say this is the object, this is the object, and this is the image. Now, if you look at the image and the object, we can see there is a relationship. First of all, they are the same in size. So the kind of transformation here is a positive quarter turn or 90 degrees. Positive is when you go anti-clockwise. That is positive rotation is when you go the anti-clockwise direction, and negative is when you rotate an object in the clockwise direction. So this means that our matrix here, which we have here, is we have our matrix that is 0, minus 1, 1, 0, represent a transformation which is a positive quarter turn or rotation about rotation. That is not the spelling. Rotation is rotation about the origin, that is 0, 0. Remember, when we are describing a transformation in rotation, we normally give the angle and the point of the center of rotation. So that matrix represents that transformation, and that is why I have said that some matrix represent a transformation which we have mentioned earlier. So let's have a look at another example and be able to see the kind of rotations these matrices represent. So here is our example 2, and we are to describe the transformation. Describe the transformation represented by the matrix so the matrix that we have been given is 0, 1 and 1, 0. So this is a 2 by 2 matrix, and we are going to follow that to find out the transformation it represents. So what we do is we take a figure. It's not always you take a triangle, but I find it a bit more convenient. So you pick a triangle. Let's just work with the one that we had in our previous example. So we will take our triangle. So we have our A, coordinates of A are 2, 1. Coordinates of B are 5, 1. And coordinates of C are 5, 4. So what we do is we can form a position vector of using this point. So we have our OA is equals to 2, 1, and then we have our OB is equals to 5, 1, and we have our OC is equals to 5, 4. You just invert the coordinates to come up with the position vector. After we do that, then what we do is pre-multiply our matrix by the matrix that will be formed from the position vectors of our triangle. So we have 0, we have 1, we have 1, 0, and then we have 2, 1, we have 5, 1, and we have 5, 4. So just like we have done, we multiply 0 multiplied by 2 is 0, 1 multiplied by 1, you get 1. So 0 plus 1 is 1. We come to 0 multiplied by 5, that is 0. 1 multiplied by 1, that will give us 1. Then we have 0 times 5 is 0. 1 times 4 is 4, so you get 4, sum of 4. 1 times 2, you get 2. 0 times 1, you get 0, so that will give us 2. That will give us 5 plus 0, that will give me 5. And we have 1 multiplied by 5, 0 multiplied by 4, we get the sum of 4, where we can now write the coordinates of, so we can say this is A, this is our B, and that is our C. And when we multiply, we get A prime, B prime, and C prime. And therefore, we can be able to write the coordinates of A prime is 1, 2. Coordinates of B prime is 1, 5. And coordinates of C prime is 4, 5. So with the coordinates of our image, we are going to use a graph or a grid to plot these two triangles, and from what you get out of the shapes of the object and the image, we will be able to decide what this matrix represents. So let's go ahead and plot these two triangles. So this is the grid that I'm going to use. We already have our A, that is our image. Our object is 2, 1 from what we have worked out. We have B is at 5, 1. We have C is at 5, 4. That is our object. And then we have what we, after multiplying, we got the coordinates of A prime, that is 1 and 2. We got B prime, and it is 1, 5. And we got C prime, which is 4, 5. So these are the coordinates. So we are going to plot that and see what kind of a graph we come up with. So let me put my values here. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that is our x-axis. We also have 1, 2, 3, 4, 5, 6, 7. You plan your scale according to the coordinates that you have. For example, if you look at the values of y, they are not below, the highest is 5 and the lowest is 1. If you look at the values of x, the highest is 5, the highest is 5, the lowest is 1. So you can plan your scale like that. Then from there, we are going to identify the points. So let's first of all plot the object, that is 2, 1. 2, 1, that is where we have our A. Our B is 5, 1. This is where we have our B, and our C is at 5, 4. So we have our C there. We join the 3 points to come up with it. So that is our triangle ABC. We can now plot the triangle A prime, B prime, and C prime. We use a different color just for the sake of seeing the difference. So we have A is at the 1, 2. That is 1, 2. That is where we have our A. Our B is at 1, 5. That is 1, 5 is there. This is where we have our B prime. That's our A prime. Our C is at 4, 5. This is where we have 4 and 5. So that is where we have our C prime. And we are going to join the 3 points to come up with a triangle. So you can see this is our object, our object, and this is our image. And you can see they are related because they are of the same shape. If you look at the position of A, it is reflected because the A and A, if you draw a line here, it is a line which passes through 0, this point. It will be A prime will be a reflection of A. The same case with C and B. So we can say the matrix that we had, that is 0. Let's use a different color. That is where we have 0, 1, 1 and 0. actually represent that is represent reflection. And let's draw the mirror line. So if you look at this line, since you have done a lot on linear graphs, this is the line. This line, the equation of this line is y is equals to x. So this matrix represents a reflection in the line y is equals to 0, not 0, but y is equals to x. Remember, when you are describing a reflection, you must give the mirror line. So that is that shows also that a matrix can represent a transformation like we've seen with this one. And I'm saying can, I'm using the word can because not all matrices will give us a transformation. So it is important to note that it is not all the matrices that when we pre-multiply with the coordinates of the object will give us an image which is related to the object. So that's how you prove that. So let's do another question. So we have an example here. So we have example. We are told identify the transformation. Identify the transformation whose matrix is we have 1 0 0 1. So we want to find out what transformation is represented by this matrix. So I'm going to use the same triangle. So we have our A is 2 1, and we have our B is 5, and we have 1, and we have our C is 5 4. So we say because we have done that, we can say the matrix formed by this is we have our matrix which is 1 0 and 0 1, and we have the matrix that will be formed by this the position vectors of this triangle. We have done that, so you remember from the previous example. So we have 1 5 1, and we have 5 4. When you multiply, I hope you remember how we multiplied the matrix. You multiply that matrix, so that is 1 by 2. Then you multiply but you have 0 multiplied by that. So 1 multiplied by 2, that is 2. 0 multiplied by 1, that will give you 0. So 2 plus 0, that should give you 2. The same case applies here. You multiply 1 by 5, you get 5, and you multiply 0 by 1, you get 0. So that means 5 plus 0 is 5. Then we have the same case. We have 1 multiplied by 5, that should give you 5, and 0 multiplied by 4, that will give you 0. So 5 plus 0 is 5. So that is how you multiply. I just thought maybe we should remind ourselves how to do that. Then you come to the second row and you do the same. You multiply 0 times 2, that is 0, and 1 multiplied by 1 is 1. So 0 plus 1, that will give you 1. You do the same. You multiply 5 multiplied by 0 times 5, that will give you 0, and you multiply 1 multiplied by 1, that should give you 0 plus 1 is 1. You multiply 0 times 5, you get 5. You add 2, you get 0. You add to 1 multiplied by 4, which is 4, and 0 plus 4 is 4. So that is how you write that in form 3. So it means that since we have multiplied that, the coordinates of our image, that is A prime, will be 2 and 1. Then we have B prime, we have 5 and 1, and then we have C prime, which is 5 and 4. So it's upon us now to go ahead and plot these two triangles and see whether we'll be able to identify the transformation. So this is the grid that I'm going to use, and we have said our object is at 2, 1. We have our B is at 5, 1, and we have our C is at 5 and 4. So that is our object. We get our image. We got our A prime is at 2, 1, B prime is at 5, 1, and C prime is at 5. That is, C prime is at 5, 4. So we are going to use this to plot the two figures that we need to do that. So let's say we can see all the values are positive side. So we can have 0, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6. We can say that is our x-axis. Then we have 1, we have 2, we have 3, 4, 5, 6, and that is our y-axis. So we are going to start with our object. So our A is at 2, 1. So this is where we have our A. Our B is at 5, 1. So that is where we have our B. And our C is at 5, 4. So that is where we have our C. And we join the 3 points to come up with a triangle. So that is our triangle ABC. Then we plot the image, and we have our A prime is at 2, 1. So this is where we have our A prime, and our B is at 5, 1. So B prime is at 5, 1, and C is at 5, 4. So that is the same position. So you find that the image, the object and the image lies on the same place. Now this is a good example to prove that a transformation, a matrix can represent a transformation, because our matrix was 1, 0, 0, 1. If you remember from your what you learned in matrices in Form 3, this matrix is known as identity matrix. That is identity matrix. And what we know about the identity matrix, it is like 1. That is, if you multiply any matrix by this matrix, identity matrix, it remains the same. It is like when you multiply a number by 1, or anything by 1, it always be the same. So this is an evidence that a matrix can cause transformation, because even the unit, even the identity matrix has shown that it conforms with what we are doing. So to wind up this, I'm going to do for you one more example involving the trig ratios, that is cosine and sine, and see a matrix that is formed using in this form, and see the kind of transformation. Here is another example. So we have example. You are told, describe the transformation. This transformation represented by the matrix we have our matrix is cos 30 degrees, we have minus cos 60 degrees, then we have sine 30 degrees, and we have sine 60 degrees. So this is our matrix, and we are supposed to describe the transformation. So what we are going to do is to find to be able to find the coordinates of our image, of our object, image, and then we will be able to plot the two figures, and we will be able to see the kind of transformation that is represented by this matrix. So what I'm going to do is I'll take a figure, triangle. I say 0, 0. I say B is is 10, 0, and we have our C. It is 0, 10. You note that it's not always that you can only transform a triangle. You can use a square, any figure, as long as you'll be able to form a matrix. So what we do is now we write our matrix and say, then this is a cosine of 30 degrees. This is a minus cosine, not sine. This is cosine of angle 60 degrees, and this is a sine of 30 degrees and sine of 60 degrees. So we are supposed to multiply that by the matrix of this triangle. So this is 0, 0, this is 10, 0, this is 0, 10. So you note we cannot multiply when it is like that. We need to get the cosine of 30, cosine of minus 60, minus cosine 60, sine of 30, and sine of 60. So using your calculator, you'll be able to, or your mathematical table, you'll be able to get the cosine of angle 30 is 0.87. That is 2 decimal places. This is minus 0.5, and this is 0.5, and this is 0.87 to 2 decimal places, and then you multiply by the matrix of the triangle. So 0, 0, this is 10, 0, and this is 0, 10, and when you multiply that, you'll be able to get this is 0 and 0, that is 0.87 multiplied by 0 plus minus 0.5. The way I've shown you how to multiply those, this is going to be 8.7, and because the other one is 0, this is going to be 0, that is going to be minus 5. Then we come to the other one, this is 0 and 0. This will be 0.5 times 10, that will give you 5, because the other one is 0. And then we have 0.5 times 0 is 0. We have 0.87 multiplied by 10. We will be able to get 8.7. So meaning that this is our A, B, and C, and this is our A prime, B prime, and C prime. Therefore, the coordinates of our image are A prime is at 0, 0. We have B prime is at 8.7 and 5, and we have our C prime is the coordinates are minus 5 and 8.7. So we go ahead and draw these two figures on our Cartesian plane. We will be able to see the kind of transformation represented by this matrix. So we have our object. We had A was 0, 0, B is at 10, 0, and C is at 0, 10. When we pre-multiply with the transformation matrix, we get our A prime is at 0, 0, our B prime is at 8.7, that is, let's write that properly, 8.7 and 5. Then we have our C prime is at minus 5 and 8.7. So it is advisable that you use a graph that has 10 small squares because of this decimal. So we have our object here, which is so if we can start from here, let this be our starting point. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. That is our x-axis. We have minus 1, we have minus 2, we have minus 3, minus 4, minus 5. Those are the negative values of x. Then we have our y, we have 1, we have 2, 3, 4, 5, 6, 7, 8, 9, and this is our y. So we'll start by plotting the object. A is at 0, 0, so that is where we have our A. Our B is at 10, so here we have 10. We have 10, 0, so our B is there. And our C is at 0, 10. So we can put our 10 there. So that's how where we have our C. We join the 3 points to come up with the triangle. So with that now, we are going to plot the image. We already have a coordinate. So A is there. So that is where we have A prime. B is at 8.7, 8.7 there, and 5. So you can see 8.7 should be around there. So we have our B prime, and our C prime is minus 5, 8.7, minus 5, 8.7. We put it there. So that is where we have our C prime. We join the 3 points and we come up with the image, or the triangle of the image. So this is the image of our triangle, and you can see this is a rotation. Our triangle ABC is rotated, center of rotation. So we can say center of rotation. You can see it is 0, 0. A is not changing, and the angle of rotation, you can say angle of rotation. You take your protractor and you measure that angle. So that angle theta, you get that theta, and that will be the angle of rotation. So that is how you work out that when you have a matrix that is involving 3 ratios, and it is still a matrix, and it represents a transformation. So that brings us to the end of this lesson. I'm going to do for you one question from the past KCSE paper, so that you can see how this knowledge is tested in a real exam. So this was a question that was tested in 1990. So this is KCSE 1990, and that was paper 1. So we are told that the vertices of triangle ABC, so the vertices of triangle ABC, we have A, the vertices are minus 1, minus 4. We have our B. Our B is 3, 3. We have our C, which is we have 2 and 5. So we have find the image of the triangle under the transformation. Under the transformation, whose matrix is our matrix there is 4, minus 2, we have 6, and minus 3. So after that, you draw the triangle. You draw the triangle and its image. On the same axis. This is axis. So Once you have that, then this question was 3 marks. So that is a question which was given. So for us to be able to solve this, what we need to do is to to form a matrix using the coordinates of the triangle and pre-multiply with the matrix to get the image. So for us to be able to do this, to answer this question, we are going to multiply our matrix, that is 4 minus 2, 6 minus 3. We multiply them by the matrix which will be formed by the position vector of our object, and that is we have minus 1 minus 4. Our B is 3 3 and our C is 2 5. So you multiply. When you multiply, 4 times minus 1 is minus 4. This will be 8. So that when you add, you get 4. This is 12 minus 6. That will give you 6. This is 8 minus 10, and that will give you minus 2. Come to the second row, we have 6 multiplied minus 6 plus 12, that will give you 6. Then we have 18 minus 9, that will give you 9. And finally we have 12 minus 15, and that will give you minus 3. So that is what you get once you multiply. So we can say this is our A, this is our B, and this is our C. This is the image of A, the image of B, and the image of C. And therefore we can write the coordinates of A prime will be 4 and 6. We have the coordinates of B, which is B prime, 6 and 9, and we have the coordinates of C, which is minus 2, minus 3. So once you do that, then you'll be able to plot the two as we are required. Draw the triangle and its image on the same axis. So we go to the grid and we draw these two figures. So this is the Cartesian plane that I'm going to use. We already have our object, we already have our coordinates, so minus 1, minus 4. We have our B, we have it is 3 3. We have our C, which is 2 5. From there we have our object, which is A prime. A prime we got it is 4 and 6. We got our B prime, which we got it is 6 and 9, and we got our C prime, which we got it is minus 2, minus 3. So we start with the object. Or first of all, let us label our axis. So that is 0. This is 1 2 3 4 5 6 7 8. That is our x-axis. So we have minus 1, minus 2, minus 3. Then y-axis we have we can have 1 2 3 4 5 6 7 8 9. So that is our y-axis. So with that we can now plot our object. Our A is at minus 1, minus 4. So we have here we are supposed to have minus 1, minus 2, minus 3, minus 4. So we have minus 1, minus 4. That is where we have our A. We can use a different color to be able to see properly. So that is our A. Our B is at 3 3. So 3 is there. So this is where we have our B. And our C is at 2 5. Our 2 5 is there, so that is where we have our C. So we are going to join the 3 points to come up with the that figure. So this is our triangle ABC. So from there we go ahead and plot the triangle ABC prime. So our A prime is 4 4 6. So for this is 4, and this is where we have our A prime. Our B prime is at 6 9. So 6 and 9 we have here, we have B, and our C is at -2, -2, -3. So this is where we have our C prime. So we are going to join the 3 points to come up with it. So this is our image. So this shows that ABC lies on the same line. So it means that our matrix, which we had, it is 4 -2, 6 -3, has transformed our triangle into a line. And that is how you are supposed to answer that question, and you get yourself 3 marks. So I hope you are comfortable with that, getting the transformation represented by the matrix. So from here I'll give you a few questions you can practice on. You can send them to my email or my WhatsApp, and I'll be able to see whether you have followed the lesson in the right way. So thank you for watching the lesson. So here is an exercise. So we have an exercise. So the first question is describe the transformation represented by the matrix. This is by the matrix. Our matrix is -1, 0, and 0, -1. So you can choose an object of your choice and transform it through this matrix, and you describe the transformation. Number two, draw or plot. Let's use the word plot. Plot, that is O, triangle P Q R with coordinates we can say that the P is 1, 1, R is 3, 1, is 3, 1, and Q is can say it is 3 and 4. So identify the transformation represented. The transformation, we can say, whose matrix is 2, 0, 0, 2. Number 3, identify transformation represented by, let me write in short, by our matrix. We have cos 90 degrees. We have cos 0 degrees, and we have sin 90, and we have cosine 0. So you can try those 3. I think we have covered most of this in that lesson, and see whether you will be able to tackle that. So let's meet in our lesson 2.